Visualizing how data actually occupies memory is the first step toward building a reliable, autonomous orchestration engine. Let's fix that. Building a state machine requires a map of the precise memory mechanics and data routing that allow an engine to operate without human intervention. Moving beyond manual script writing means designing a system where every execution path is predefined within the architecture. We will trace this path from the initial database trigger through to a multi-API fan-out router. We are focusing on the interaction between stateless LLM logic nodes and persistent memory contexts. The engineering goal is to architect this entire system from scratch in under 2 hours. Software engineering at this scale involves orchestrating autonomous data pipelines that manage their own state. The architecture starts with raw variables resting within a master database, like Notion, awaiting a state change. We replace manual inputs with a specific field mutation, such as a status changing to approved, to act as our trigger. The webhook captures this localized state change and alerts the system immediately. To maintain efficiency, the webhook passes only a lightweight JSON pointer rather than the entire database. This interrupt-driven model eliminates the need for resource-heavy polling loops. Turning a static database into an active trigger is the foundational step in removing human intervention from the execution pipeline. The webhook's JSON payload arrives at our orchestration layer, N8N. This logic layer functions as a directed acyclic graph, or DAG. The data enters the root of the graph and reaches the AI agent node. The agent passes the raw payload to the Claude 3.5 Sonnet API for transformation. The API's response data moves through parallel execution paths, branching outward simultaneously. Path A generates a 280-character string optimized for X. Path B generates a formatted long-form post tailored for LinkedIn. The DAG architecture ensures these two threads are processed concurrently. This structure allows a single raw input to be mutated into multiple platform-optimized variables instantly. To finish the build, we have to address the primary limitation of foundational LLMs, inherent statelessness. Models like Claude 3.5 process data in a vacuum and have zero native memory between API calls. Without structural intervention, every new prompt resets the model's context window, breaking the continuity required for an assistant. True autonomy requires an external architecture to compensate for this lack of native memory. The solution is a persistent memory database layer. While the LLM flushes data, our vector database accumulates it. The system treats conversation history as a persistent data structure. Every new interaction is appended as a sequential node in a linked list. The system queries the database to retrieve this chain of previous nodes just before the next API call is made. Re-injecting this history into the payload at runtime simulates an unbroken memory stream. The performance of a context-aware assistant is a direct result of the memory allocation and retrieval structures wrapping the stateless API. The finalized text variants now leave the orchestration graph via an HTTP request. They finally reach the distribution router, make.com. The routing engine utilizes a fan-out distribution algorithm to send the data to its final destination points. Path A connects to the X API to publish the short-form post immediately. Path B connects to the LinkedIn API to schedule the long-form post for peak engagement. This fan-out architecture acts as a firewall. Network issues on one platform cannot bottleneck the execution of the other. A distributed state machine must verify its own execution to complete the cycle. This triggers the confirmation loop once success codes are received from the external APIs. The confirmation signal travels from the routing endpoint back to the origin database node. The system automatically changes the state from approved to published and appends the live URL for tracking. This advanced architecture chains stateless AI logic with multi-app routing and persistent memory to create a powerful, self-sustaining engine. Transition from manual execution loops to event-driven state machines. Deploy your memory layers, refactor your routing logic, and let your systems manage the scale.